As mentioned, my name is Sam Nasr, and I'm a senior software engineer for NIS Technologies. You can find me on Twitter at Sam Nasr. I've been developing software since 1995, engineer as well as instructor for NIS Technologies. I've been certified with a few certifications from Microsoft, and the two biggest feathers in my cap are the Cleveland C# user group, free of charge and open to the public. So hopefully you can join us at or both of those meetings. I've also authored multiple articles for Visual Studio Magazine. I've done some course content for LinkedIn Learning and also written some articles for Twilio. In addition, I'm a 7-time Microsoft MVP, specifically in the AI space. However, tonight's topic is going to be on temporal tables. And what temporal tables are basically time period tables where you can explicitly define the validity period of a specific row, meaning you can show when that row was actually valid at a specific point in time. So temporal tables is another name for system version table. It's based on an ANSI standard, and it is a new feature in SQL Server, but not all the temporal features are supported if you've worked with them before in other databases. It maintains current and past states of modified rows without having to do any backups or restores. It's basically right out of the box, and you access it all using T-SQL. It's a standard feature for all editions of SQL Server 2016 and later. And everything is implemented within T-SQL. So there's no behind the scenes. I don't have to talk to a DBA to get this implemented. Everything is done dynamically via T-SQL. So table requirements. First, I would need a primary key. Second, I would need 2 period columns. And these are going to be date time 2 types, where essentially it's going to be the start column and the end column. And then I will utilize the clause period for system underscore time as listed there in the 3rd sub-bullet. Another requirement is that I need to specify system underscore versioning is on, and this is all specified when I'm creating the table. And we'll get a better look at this once we get into the demo. But these are the requirements right off the bat. And then in addition, I can specify the name of my history table, or I can leave that blank and then SQL Server will give me a default name. So taking all this into consideration, what does that look like when I actually implement it in T-SQL? As you see at the lower part of the slide, essentially I use my create table T-SQL statement, and then within it, I need to specify all the 4 requirements. So the first one is the department ID, where I set that to an identity field, and that's going to be my primary key. And then if you scroll down, you'll notice that I have a valid from and a valid to, and these are date time 2 types as specified in the second point. And I also add the clause generated always as row start, not null, meaning it's going to be system generated, and that field is not null. Same thing with the row end, beneath it valid to, also a date time 2 type. It is system generated, and it is also not null. The third requirement is that I have the system versioning on. That is the last clause at the bottom of that table. And I went ahead and specified a default name for my history table. And so what ends up happening is I'm creating now essentially 2 tables for the price of 1, so to speak, or all using one T-SQL statement. So I have my department table, and then we'll see once we start the demo that there's also a department history table that's been added on as well. So when I need to query it, essentially I do it just like I would any other T-SQL statement. Select star from department, except here I can add in a system time, and I can specify when I want to query that data at one point in time. So I'm specifying up, and then using the date add function, where I'm going back 30 days in time from the current time. And I embed this in my, and where I can also add a order by statement in addition to that query. So usage scenarios. It allows for querying a table at a specific point in time. It restores from tape or from a backup, and it's all dynamic, all within the same database. It's used for slowly changing dimensions of a data warehouse. So if I have, and data warehouse is a bad name here, but essentially in a database where I have slowly changing fields, meaning that it is not highly dynamic, real time, where I am changing a lot of records, but rather it's relatively slow. So if I'm changing a customer phone number or customer email, these are things that don't happen regularly, or rather many times a minute, but it may happen on a regular basis, meaning once or twice a day. And so these types of dimensions are the ones that would be ideal for this type of scenario. It audits of when the change was made, not who. So we can go to a specific point in time when that record was valid, when that specific row was valid, but it doesn't tell me necessarily who made that change. So utilize features in SQL Server, or I can put in my homegrown solution to identify who made that change. So this is also useful for recovering from accidental loss of data. If I have a junior developer who accidentally did delete from the table without specifying a where clause, obviously all those records are gone. But again, with one simple T-SQL statement, I can restore all those records back without having to do a backup. It's also used for anomaly detection. So now that I'm maintaining historical data, I can see how the changes are manifesting themselves within the database. And so I can track anomalies. If a change is out of whack or doesn't seem right in comparison to changes, then I know that there's an anomaly that's happening. So it's also used for repair data corruption, meaning if there's a specific row that has been corrupted or a specific field within that row, I can go back to my historical table and then be able to retrieve the true version of that row. So for enabling temporal tables, it must be done in two separate statements, meaning if I already have a table that's already existing, let's say my employee table, and I need to make it system versioned or temporal, then two separate things. For existing tables, it must be done in two separate alter table statements, where as we excerpt on the bottom, I am altering the table employee, and I am adding a start date, an end date, and then I'm specifying the period for system time clause, those two fields that I added, start date and end date, and using those for my period system time. Looking at end date, you'll see that it meets the criteria that I specified earlier. Has to be date time 2, has to have the generated as row start and generated always as row. And in addition, not null. If I'm using a new table and I want to make it temporal, meaning I'm creating a new table from scratch and I want to make it temporal, right, then enable it in the create table T-SQL statement, and we'll see that once we get into the demo. While querying it can be done within the standard T-SQL, and there are 4 different clauses that allow me to do that. There is specify the start to end time. I can in or contained within. So they all sound very similar, that I'm specifying a point in time, but if you look over qualifying on the right-hand side of that slide, you'll see the differences lie in the less than and less. So for example, less than the that's specified. So that's where the differences lie, is in the less than or equal to, and vice versa, end of that statement, greater than or equal to. And so with that, I want to pause for just a moment, take a look in chat and see if there's any questions. And again, feel free to raise your hand or jump in verbally, whichever is more convenient. Go ahead, Steve.
So you're applying this on a table basis and you're rolling forward or back. And how do you maintain the integrity of the database if you're just doing one table?
That big question, integrity. Okay, so essentially, it's probably better demonstrated in the demo that we'll run through in just a moment. But there's essentially, when I have system versioning turned on, that historical table cannot be modified. It can only be modified when I turn system versioning off. And of course, I need specific rights to do that. And then when I turn it back on again, then it does a system check to see that things are kosher. Certainly, I can modify the historical table by purging it, but things need to still, if I was to make a modification within that historical table, the sys end and the sys start time need to match with the current table as well. And again, that's going to be better demonstrated once we get into the demo.
Okay, that answers my question.
Very good. Any other questions or comments? All right. So with that, let's jump into our demo. And let me open up Management Studio. And so what I have here is basically a script. And this is available on my GitHub. And essentially, it's intended so that you can run the script multiple times over again. And so I have it where it drops the database and it creates it from scratch. And so even though I have a pre-existing demo, I'm going to go ahead and drop that. And I need to be out of that database. So we'll try it again. That database is dropped. Now I'm going to go ahead and create my temporal demo DB. And we'll do a refresh. And just to show you that I'm staying honest, I'm going to expand the tables folder and you should see nothing within it at this time. Now, what I'm going to do is I'm going to create a territory managers table, as we see here. And then in addition, I'm going to create a customers table. So the territory managers, as like the name suggests, managers for specific territories. And then we have customers that are attached to that territory managers via a foreign key. So first things first, let's go ahead and create the territory managers. And this is a standard table, not temporal or historical. We'll go ahead and click execute. That's created. Now, customers table. You'll notice that this table has a few interesting fields. So first of all, we have the identity field. That's normal. But then we also have the sys start time and sys end time. And the date time too, generated always. And then I'm specifying that as the row start. And same thing with the sys end time. And then I'm using those two fields in my period clause. And then in addition, I'm specifying system versioning as on. I set the history table name to customer historical table to match the customers table. And then I went ahead and added in a retention clause. So it's going to retain records for 6 months. And I'll go ahead and, did I create my territory managers? Let me refresh that. Yes, I did. So now we can create our customers table. And you see the commands completed successfully. And then before I forget, I'm going to add in the foreign key so that it ties the territory managers with the customers table. And essentially what this is doing is this territory manager ID is going to tie it to the ID field in the territory managers. So every customer is assigned a territory manager. Now let's glance over at the temporal DB and I will refresh that. I'll expand my tables and then let me zoom in. All right, so you'll see that I have my customers table, and you'll notice that right alongside that there's a system version specified in parentheses. In addition, the icon for it is slightly different where there's a clock on it in comparison to my territory managers table. When I expand that table, you'll see that there's also another table underneath it called Customers Historical Table, and you see history defined in parentheses. When I expand the columns for my customers table, there are all the fields that I specified, but then in addition, I can expand the customers historical table, and it's almost a one-to-one match. The only difference is this primary key that's an ID field in my customers table is not a primary key in my historical table. And the reason for that is my historical table is essentially my data warehouse table, so to speak. That's housing all the records that are being changed. And when you have a historical table or a data warehouse table, you tend to not have a primary key because that's going to be not so primary. That field is going to be repeated multiple times, and we'll see that in just a second. But in the meantime, wanted to check, everyone with me so far, or any questions? All right, so far, no hands, thumbs up, very good. So onwards and upwards. All right. So I already added in my foreign key constraints. Now I'm going to insert some records. So I have 3 territory managers, and then I have customers that I will affiliate with those territory managers. And now I'm going to select from all 3 tables. From territory managers, I see 3 records. From my customers table, I also see 3 customer records that are assigned to those individual managers. But then that third table, this customer historical table, you'll see that it is null. Sorry, not null, but rather blank. And that's because I have made no changes. This is just my data as I had just entered it in. You'll notice the sys start time has the date time down to the seconds of when those records were inserted. But then you look at the end time, that is year, and let me zoom in. That is year 9999, December 31st, right at the stroke of midnight. So essentially, this is the SQL Server equivalent of saying infinity. So this record became alive at this date and time on December 11th, 2024, and it lives on to infinity. So with that, let's get back into making some changes into our table. But before we do that, if I query my sys tables, I'll see that there is a type called temporal type. And when I query that on these 2 tables, customers and customer historical table, I see that the customers table is listed as system versioned temporal, and then the customer historical table is listed as a history table. So in this history table, that's where I maintain my history, as the name suggests. And then everything in the customers table is just the latest records without the history maintained in them. I see there's a question in chat. As someone who had worked with temp table columns named systart and end time in hindsight, valid from, valid to naming convention would have been more helpful. True, and you do have the option of naming them as you wish, as you had seen, as I did in my SQL. And getting back into our demo. So when I select from the customers table, as the description states, it just appears as a user table. Now, let's go ahead and make some changes to it. I have a customer who's going to be changing her email quite often. And the reason it's going to be quite often is because our presentation is only an hour long, right? So I have a script where it's going to change the email First, it's going to wait 3 seconds. Then it's going to change the email to a yahoo.com, wait another 3 seconds, change it to a hotmail.com, and then another 3 seconds and change it to a mailx.com. So we'll go ahead and execute all three. And while we're waiting those 9 seconds, I heard a little joke that said, if you have a Hotmail address, chances are you have back pain every evening. I thought that was funny. But in any case, so we have 3 records that have been modified. Now, when I look at my customers table, it still shows just the 3 records. And of course, Tina still shows the mailx.com email address because that was the last update that I made here. However, let me query both tables so we can compare them. I see in my customers table, I have 3 records, and allow me to zoom in. I have 3 records, Lisa, Tina, and Sam, but then in my historical table, I see that I have 3 records, all for Tina, and the ID fields, which is my primary key in my customers table, it is not a primary key in my historical table because it's the same ID repeated multiple times. So, and the reason that that's happening is because Tina had changed her email 3 separate times, and then looking at the sys start time, so she used an Outlook address that was valid from December 11th at 6:35 until 10:01. And then she used the Yahoo email address from 10:01 to 10:04. And then the Hotmail from 10:04 to 10:07. And then looking at my customers table, this record became valid, the entire record, including the email field, became valid at 10:07, and it stays valid until infinity or until I change it. I see there's a question in chat. What do you think about organizing history tables into a history schema? Would that be of value? Certainly, and so that's one good way of managing security around the historical table. So yes, that's certainly an option. Another question is, will sys end time or valid from ever be anything other than 999 December 31st? Only in the historical table, because in the current table, it's only current only if that sys end time is infinity. The only way to change it is if you delete that record, and then that record is no longer in the customers table, but will rather be moved into the historical table. So you'll notice in the historical table, there are no 999 year, but there is in the customers table. That is my current table. Does that answer your question, Lee?
Yeah.
All right, very good. Okay, any other questions or comments? Very good. Always feel free to jump in. And now that we have our data, some sample data to work with, we can start querying it. And so since the dates are date time 2 and there's a lot of numbers to enter, I'm going to do a little bit of cheating by copying a date field, and specifically for Tina's Yahoo. So let's say I didn't know what Tina's email was at that point in time. And Tina called customer service complaining that she never received an email verification for her order. So now I can query it at that point in time. And she'll say, well, my email is mailx.com. How come I never received my verification? And now when I query it to that point in time when she made the order, I can say, well, at that point in time, it was set to the Yahoo email address, and that's where it went. So for querying it, I'm just using the system time, and then I'm using the as of. And if you recall, there are 4 different clauses. There's between, from, as of, and then the 4th one, which escapes me at this time. But that was all on the slide that we discussed earlier. In the same manner, I can just select it for a very wide date range and see what things were, historically going back to 2022. And again, I'm using extreme past as well as extreme future. And I query that. And what it does is it essentially unions the two tables, and then it gives me all the fields, both current as well as the ones that were changed. So there I see the four records for Tina, the three historical ones, as well as the latest one with this male X. And there are the previous three, as well as the other records that have not changed. And all I did, I queried the customers table, and then I specified the system from. I didn't have to do a union. I didn't have to do a restore. I didn't have to point it to another table. It was all looking at my customers table, and I specified the system time, and all that happened on the back end automatically for me. So contained in, that was the fourth clause that has escaped me. All right. So here are several examples that essentially utilize the same thing where I'm querying in between specific date time periods. The one thing to watch out for in reference to the slide that we discussed is whether it's greater than or equal to that specific date. But essentially, they do the same thing where they're querying both tables at once, dependent on this system time clause, and then it brings everything back automatically. So if I was to select it, let's say I can specify system time all from the customers table. And what that does, the same thing, where essentially it brings everything back as the clause specifies, all. Now I can narrow it down where it's just ID equals 2. I want to look specifically at my user Tina, and then I want to order by the sys start time. So I'll go ahead and query that, and you'll see that I'm able to order by the sys start time field. So I'm able to sort on that field, but I cannot modify that field. And so it lists everything for Tina in the order of the sys start time in ascending order. So I have the oldest record first, and then the newest record at the very end. Likewise, I can look specifically into the historical table, looking at and you notice here that I'm specifying the sys end time less than 9999, meaning anything less than infinity. And if I execute that, it brings everything back that I have in my customer historical table. Okay. Next thing you're probably wondering, well, what would happen if I use transactions? Well, I know you didn't ask, but I'm glad that you're thinking it. And so with that, we'll get into a transaction. And what we're going to be doing here is we're going to specify a string that we're starting the transaction at a specific point in time. We're going to update Tina's record. We're going to delay 1 second, update it again, delay another second, and then update it a third time, and then specify the end time. And then we're going to commit the transaction. So let's go ahead and highlight the entire portion. And the reason why I'm delaying it 1 second. Go ahead and execute it. Everything ran successfully. When I query both the customers and the customer historical table, again, I only see one record for Tina in my customers table. However, looking at my historical table, you'll see that I have 3 more records because of the 3 more updates that I did for Tina. And more specifically, if I look at those records, now you'll notice that I made 3 updates with 1 second apart for each update, right? However, if you look at the time, the sys end time is identical for all 3. And that's because, as stated here, all right, maybe I didn't state it, but I'll say it. Essentially, the end time will be the same for all three records when that transaction has completed. So that's one thing, one little caveat to note when executing transactions is that even though there's a delay in between, the final timestamp gets stamped on all three records. Now, what if I try to update a historical table like the customer's historical table, and I want to change Tina's email address again? I'll try to execute that statement, and you'll see I get an error message, cannot update rows in a temporal history table. What if I try to delete a record? So if I delete the record for Tina from the customers table, and then let's query both tables for comparison. You'll see that I only have two records in my customers table, but then I have multiple records in my in my historical table for Tina, and more specifically, the one that I deleted most recently, which is here. Now, if I attempt to delete a specific record from the historical table, again, I get a message stating that I cannot delete rows from a historical table. All right, let me pause and see if there's any questions. Someone is typing in a question at this time. And again, feel free to jump in either verbally or through the chat. All right, while we're waiting for that question to be entered, the next thing that I want to demonstrate is the alter statement. So obviously, none of us have implemented a table in production, and that table had forever stayed static. There's always changes that need to be made. So what if in the case that we need to alter a table, how will that impact a historical table? Because we're now working with two tables instead of one. So if we, here in this demo, we'll go ahead and alter the customers table. We'll add in another alternate email address. And when we execute that, and if you'll notice, it was only on my customers table. However, when I look at my customers and customers historical, you'll see it automatically added in a field. Pardon me. It automatically added a field in. The caveat here is that it needs to be null because it simply, the database engine won't know how to fill in historical records for this new field. So if I try to do the same thing, but specify that it's not null, I'm adding in an alternate email to into the customers table, and I'm specifying it's not null. And as you see in the comment here, it fails due to not null, and there's the error message that I must specify either a default or specify it as nullable. And the question in chat. So in the transaction example, is there no way to be sure which item was last? So if we look at the customers and customers historical table, yeah, that is correct. Because they all get the same date and timestamp. You'd have to do some magic around it. Get a little bit creative, but by default, yeah, for a transaction, if you're doing that many alterations, then the last date and time, or the last the date time of the commit gets stamped on all the records that have been modified. Another question. Inability to add non-null values is a major deficiency. No way around that. Default value doesn't help. Well, So a workaround, as we'll see later, you could turn the system versioning off, make your changes, and then turn system versioning back on. But when you do that, it does a check to see that everything is kosher and still maintained integrity in your data. And we'll touch on that a little bit later in a demo. But yeah, you can do some workarounds, do some manual intervention with the system versioning turned off. All right, I'm really enjoying these questions. Please keep them coming. And again, jumping in verbally is an option, so don't hesitate. And if no questions or comments, we can move on. All right, so we saw that we cannot modify it with a not null. Now here's where we turn the system versioning off when making custom changes. And we're going to do this in a transaction. And this is a little bit of a long one. So what we're doing here is we're beginning the transaction. We're going to turn the versioning off on our customers table. We're going to apply changes. We're going to add customer notes fields that is null to both customers and customers historical. We're going to update the cust notes field to be customer rec for all the fields in the customers table. And then we're going to specify old rec for customer notes in the customer historical table. And then we're going to turn system versioning back on. And then here, this is where the data consistency check occurs. And we'll go ahead and execute that. Now, at the very end, when I turn this on with system versioning, I'm specifying my name, the name of my historical table, because what I did was I essentially detached them. And now that I'm reattaching them again using system versioning on, I need to specify the name of that historical table, as well as be able to do a data consistency check, meaning all the columns need to be in alignment with the customers and the customers historical table. So there I did some manipulation where I modified my fields separately in customers and customer notes. And then if I query those two tables, we do select star from customers and select star from customers historical table. Do we have any DBAs in the crowd, by the way? I assume not, since no one yelled at me for using the select star from. Maybe kind of once upon a time. Yeah, weren't we all really? Maybe once upon a time. But in any case, so I'm selecting from both tables now. And I see that I have the same number of columns in both customers as well as the customer historical. I have different data that I was able to manipulate in the historical table versus the customers table. FoxPro DBA, wow. You know, there's a FoxPro group in Toledo that, as far as I know, still meets once a year to discuss various topics. But yeah, FoxPro is, it's a cult following. DBase 2. Please, I haven't had dinner yet, so let's not go there. All right, Clipper, very good. Okay, so getting back to our demo. So we're able to update specific fields. If we go into our customers table, once I update the email for the customers field. And this is where ID equals 3, because ID number 2 has been deleted. So I see that I was able to update it for the third, pardon me, for ID 3. And then I see that there's also a historical record that appeared in there And then you'll notice that now cust notes just simply takes in what the customer notes field was in the customers table. It is now copied over, meaning it did not retain the old rec string for the new records that were inserted in the historical table. It just simply copies that over. If I delete a record from the customers table, so now my customer table only has one record, ID 3 for Sam Johnson. Everything else has been moved over into the historical table in the order that it was deleted. You'll notice my sys end time still remains at year 999, whereas the sys end time is basically the time when that record was deleted from the customers table or updated. All right, any questions before we move on to purging? Okay, so moving right along. So you recall that I set the historical retention to 6 months when I created the table, and that was done at the very beginning when I created the table. But now we want to purge records, so what we can do is we can set the versioning to off. Now we have full flexibility where we can remove only specific records for that ID2. And we see that 7 rows have been deleted. And now we can turn system versioning back on again. Now when I select from customers and customer historical table, I see that everything for Tina has been removed completely. So now if I need to go back and retrieve records for Tina, now I actually need to dig into my backups for that. That's been purged from the historical table. Looking in the chat window for a question. False alarm. Okay. So as of now, the system versioning is on, but I will try to update the customer historical table and set the first name to Christina instead of Tina, where ID is 2. And 0 records were affected because that record is no longer there. In addition, I can truncate from the customers table. And how many know the difference between truncate and delete? All right, so truncate will essentially remove everything from the table and not write it to the transaction log, as opposed to delete, which will write it to the transaction log. So, and yes, truncate does require DBO permission, but essentially, once I truncate, that's it. There's no record, there's no evidence of those records unless I have to go to a backup. So I can truncate table from customers, or at least try to, because as we see here, it is not a supported operation with the system version table. So versioning is on, therefore it will not truncate that table. However, if I turn versioning off, truncate the table, and turn it back on again, now we're good to go. And you'll see that even though I truncated the table from customers, that remaining record, which is ID 3, had been moved over into the historical table and is retained there. All right, moving to the final portion. What we're doing here is essentially 3 different ways for creating the temporal tables. And so you'll notice that here it's going to create an anonymous history table. So meaning I'm going to create the table. I'm going to follow most of the requirements that I specified. Let me rephrase it. I'm going to specify the minimum requirements that are required for creating the historical table, i.e. the primary key, sys start time and sys end time, the period clause, and then versioning on. I will not specify a name for the historical table, and I'll leave that for the database engine to do that for me. So I'll go ahead and create department 1. And if we look over into our tables, let's go ahead and refresh that. We'll see that I have a department 1 table. And if we zoom in on that, so there's department 1, it's set to system versions. And then you'll notice the default name, kind of messy, that was created for me right off the bat. dbo.msql temporal history for 1029578706. Kind of rolls off the tongue, right? So that's the downside of not specifying the name of the historical table. Now, the second option is I'm going to specify my historical table. And that's similar to what we've seen before. And so again, we do a refresh and we see the table department 2, and it has a department 2 history with a nice naming mechanism that we can follow. Now, the third one is kind of quirky in the sense that I'm creating my history table, and then I'm creating a department 3 history table. And here I am modifying, I'm utilizing the column store index for specific fields on the department history table. So this gives me flexibility where I can specify my history table and then reference it during the creation, as opposed to what I did here with just simply specifying a name. I can actually specify the schema. And let me go ahead and execute that. Schema is a bad term. I can specify the structure for my table. So it's not recommended because it has to be exact in order for it to work. But let's go ahead and execute that. So I went through the pain of actually doing that and setting it up. Now, if I was to add in an additional field in my department 3 table, actually, let's do this. Let's do a refresh. And we'll see that I have department 3, and then I have department 3 history table associated with it. Now, what I'm going to do is I'm going to delete department 3. Actually, let's do this instead. Let's create a department 4 and really mess things up. And here's what I mean by that. So we're going to call this department 4. And you'll notice this one has a region ID, and it is null. And then this is going to be department 4. And this is going to be a country ID. So the fields are not going to match as far as name, but type. And we want to make sure that all of our name conventions are legit. So we got department 4 history, department 4. We'll do department 4 here as well. All right, so I think we got all the bases covered.
One more.
One more.
On department 3 history, create column store index. On department 3 history, it says.
Good catch. Thank you. All right. So now we'll highlight the entire portion. And we'll see that system failed because column region ID essentially does not match the parent department ID. So it's looking for basically there's a mismatch of the column names. And so that's why it's not able to turn the system versioning on for those two tables. Okay. So as I mentioned, if you're creating your own table structure for the historical table, there is the option to actually shoot yourself in the foot, just like I did here. Of course, here I did it intentionally, but the better way to go is the second option. Just simply specify a user-friendly name for it, and then let everything be managed by the database engine on the back end. All right, so with that, I think that's all I have for tonight. Any questions before we move on to the remaining slides? Yes, go ahead, Lee.
I'm just curious about entity framework support. Oh, other Lee, sorry.
That's okay. So entity framework support, yes, it is supported by EF Core.
And my question was, in the Object Explorer, I'm noticing the temporal history that was system generated has its own entry there, but the others are just nested under. Is that the same temporal history as is under Department 1?
Are you saying for this
Is
table that I have highlighted?
Yeah, is that table the same table that's nested under Department 1?
So this was created for when I created Department 1, correct. Now, is it the
Right.
same name? Let me verify that. So if we look at Department 1, no, it is not.
Okay, so it's some other.
Correct.
Got it.
Steve, go ahead, please.
So we're essentially creating multiple transactions or saving history for one table. So that table's going to take up X amount of space, but our history tables are going to grow significantly. So are we seeing like a huge amount of storage space that we've now like tripled, or I don't even know what it would be? And in that second part is what about our hit on overall performance?
Great question. So I will give you the ubiquitous developer answer. It depends. And what does it depend on? It depends on the number of columns you have in that table, depends on the indices you have on that table, and then how big that table is going to grow, and then more importantly, how much is it going to be modified? So let's say, for example, I have a table where I am not making a whole lot of changes. Hypothetically, my customers are very easygoing. They don't make any changes to their email or phone number. Then I'm not going to have anything in my historical table, right? However, if there's changes that are constantly being made, then I am basically, for every change that's being made, I'm duplicating the records in that table. The columns need to match up. So essentially it is double the work, so to speak, double the storage. But it only depends on how often they're making updates to that table. So there's a lot of it depends there. In addition, as far as history, if you'll notice in the very first example, where I'm creating the table, I have this history retention period. So it will automatically retain history for me for a specific amount of time. After that time has expired, those records just drop off. And then either I have to go to backup or just let them go if they're not that important.
And then the second part was performance. Are we seeing like a big degradation in performance, or?
So again, it depends, sorry to say, but the number of indices that you would have on that table, and then how often you're querying things that are related to the system time. So I can query a customers table. That's not going to have an impact by me doing this, right? Selecting from customers. However, There was another example. Like when I do this, and I'm specifying systime all, what this is doing on the back end is essentially it's unioning those two tables for the specific criteria. You see what I'm saying?
Yes, I understand what you're saying.
Yeah. So I don't have a concrete answer for you because it's just it'll vary depending on your application. Yeah, I would say test it, but again, it just depends on how often those changes are going to be made to that.
Okay. Yep, that answers my question.
I have another question. Mr. Abib, is it a mist?
Yes, that's correct, Sam.
Yes,
Thank you for your presentation.
you're
So,
very welcome.
kind of quick check on 2 points. Number one, I believe on the second slide you mentioned about it doesn't tell us who, but is there any possible way to know who did that change using this, option of temporal tables? Number two, like from the best practice perspective, if we need to recover, are we going to use the scripts to kind of repopulate it into the primary table, which is the original one? Or if there is any kind of issue happens and if we need to recover from the temporal table, what are the options to recover from there? And maybe a final related point would be best practice. When are we going to use this kind of method versioning tables? Like historical ones as well, best practices or general topic in relation to this one. Thank you.
You're very welcome. Okay, so let's go through those questions again. So can you recover from a historical table fields or a row from the historical table and you're inserting it the customers table? So that's one quick way to recover. Now, you had two other questions. If you could run, your audio was
Yes, second one was like, is there any way to know who did that change?
so with this functionality right off the bat, no. As I mentioned earlier, it does not tell you who did it. It only gives you the time of when those changes were made. So that was have to use other features from SQL Server or bake it into the application so that any updates who made.
Okay. And I think the final one was like best practice. When are we going to use such method, temporal table or versioning?
So you would use them for slowly changing dimensions, meaning fields that are not changed regularly. Like if you're collecting weather data by the second, that's obviously heavily changing and it wouldn't be a fit for that. But there are some applications where it is not a fit, such as, for example, bank transaction. From a bank, I don't want to have the ability to go back and modify that record historically, nor do I want anyone else to have that ability, right? If I make a deposit, that deposit permanently stays there and it is recorded as a deposit. I don't want that record to be modified at a later time. So it has a basically whenever you need to maintain history where you would need to resort to it. It is not something to, your entire, because as we had seen, it is essentially duplicating the table structure for every table, right? So it's for slowly changing tables and for tables that you need to maintain history on. Things like bank transactions and other things you don't want to maintain history on. Let me rephrase it. You don't want to maintain change history on them.
Oh, all right. Thank you.
You're welcome. Other questions, either verbally or in chat, feel free to jump in. Lee has a question. If you use ABP framework, It has auditing that would combine very nicely with temporal tables to give who changed and who created it. I can't say I'm familiar with ABP. What is that short for, Lee?
It used to be ASP.NET Boilerplate, and it is now a framework that is a boilerplate framework that sits on .NET. I actually have a presentation on it as well. So if you're interested, I've been using that for the last couple of projects I've worked on, and it's absolutely lovely. And yeah, it gives you it's all entity framework based. It assumes you're doing EF, and if you have your entities inherit from it's called a full audited aggregate root, then it just automatically adds the created date, created by, modified date, modified by. It gives you soft deleted capabilities as well. And then yeah, it's a great framework, and I think it would combine very nicely with the temporal tables.
Nice. So that would be happening on the application layer.
Right, which I think it makes the most sense for auditing to be at that layer, to me anyway, because at the database layer, like if you've got an app, it's that, from SQL Server's perspective, the only who did modify or who did create information it can give you is the person that logged into SQL Server. And if you have an app, that's just going to be the app. It's not going to be very helpful.
Exactly. Yeah, I completely agree with you. There are features within SQL Server that record the current user, but exactly like you said, if you're using an application connecting to SQL Server, it's going to be using that same user ID for all the users logging in. So it's better to do it on the application layer. And then we have another user who's asking, I missed the first part of the presentation, so this may already have been shared. When you turn system versioning off, even though the history table stops capturing updates, the system columns in the non-history table continue to be captured as long as you don't drop the system time period. That is correct. So if we query from the customers table, we'll see that we have the sys start time that continues to get populated, whether I have system versioning on or off. If I have it off, obviously I'm not maintaining a history of records there, but the sys start time always gets populated. And let me actually go back to the very beginning and populate my customers table. There we go. And then we'll see that my customers table have the initial 3 that I put in, but the historical table still has the 3 that I ran. I'm sorry, the 2 records that I ran or deleted previously, they show in the historical table, but you'll see the sys start time is always getting populated. And to further emphasize your question, we said when system versioning is off. So let's go and alter the table and turn system versioning off. And so alter table, turn system versioning off, and then we'll go back here and we'll insert 3 more records. And you see that I continue to populate into the sys start time, rather. And it's not affecting this. Let me rephrase it. I populated into the customers table. The sys start time continues to be populated. Unfortunately, that is an unverified user, so I don't have a name, but I hope that answers your question. Any other questions or comments before we continue on with the remaining slides? All right, so with that, let's move forward. So I already did the demo, some design constraints. Keep in mind that the file stream type is not supported. If you're not familiar with file stream, that is one of the coolest features that's been in SQL Server, and it's been there since 2008. Basically, it allows you to create a pointer to a file that's sitting on the in the system tables on disk, but it doesn't bloat the database. It's only a pointer, and it's all built in within SQL Server, so it helps you to manage security without bloating the database. The point is that file stream data type is not supported in temporal tables. As we mentioned, the history table cannot be modified directly. You can only add to it by updating or deleting from the current table. Instead of triggers are supported, and after triggers are only allowed on the current table. Some design constraints: you cannot change the schema of a temporal table without changing the current table schema. As we had seen, the columns need to match one-to-one for both current as well as historical. And also, as we had seen in the demos, changes to the current table will automatically be reflected on the temporal table when the versioning is on. Indexing must be manually enabled, as we had seen as well. And whenever we turn the system versioning on and we specify do the system check, I'm not going to go through all 10, but essentially this is the list of items that it goes through in order to be able to ensure that there is data integrity before resuming the versioning process. And some security principles to keep in mind as far as who's allowed to turn versioning on or off. And again, I'll make this available in the slide deck later. But some best practices. For converting an existing table, consider using the hidden clause, meaning obviously if you have an existing table, you need to add the sys_start time and sys_end time. So you want to set those fields as hidden, because if you have some code somewhere that does a select star from, it's not going to know what to do with those two new fields. So those two fields are required, but if you set them to hidden, it won't impact any existing applications. Pay close attention to the less than or equal to. This will dictate which of the 4 subclauses you'd want to use when querying the data. And as Lee had mentioned earlier, it is a good idea to use a separate schema for the history tables. So we had talked about capturing the changes. So there is a change tracking. There's the one thing to keep in mind. There is temporal tables, there is change tracking, and there is change data capture. All 3 are native features within SQL Server. It's just a matter of finding out what suits you best and how to implement them. So with temporal tables, we saw that it stored the entire row and the date and time of when that row was actually valid in its entirety. With change tracking, it stores the last change made to that row, so there's no history. And then CDC, or change data capture, captures the data manipulation language for that table. However, as noted in the last bullet, it requires database owner to be a sysadmin to be able to implement that. So again, it's all about knowing the various features, the pros and the cons, and what works best for you. So as a recap, we talked about temporal tables, how they can be implemented on both existing tables as well as new tables. We talked about the requirement for having the sys_start time and the sys_end time, and I can name those fields how I want to name them, whether it's valid to or valid from. We talked about how we can query everything all through using T-SQL, and I can use clauses such as in between or contained or as of to specify the time frame of when I want the records of when they were valid. And it will union, I can do system all as well, and it will union everything from the historical table as well as from the current table. Some additional resources. Lenny Lobel did a good write-up on this. And again, this is a feature that's been around since 2016. Unfortunately, not many people know about it, but I find it very valuable, and I think it's a great feature to have. So there's some write-ups on it available through Lenny's blog, as well as on infoq.com and Microsoft as well. If you're interested in having this as a course to your group or your coworkers, We offer this as a course at NIS Technologies. I am one of the instructors and would be happy to work with you and get this implemented. In addition, there's also a variety of other courses available on our website. And so with that, my contact information, please, I can't stress this enough. Just because the presentation's over doesn't mean the dialogue stops here. I have many people in the past that have reached out to me with questions after the fact, and we're able to communicate and launch projects and get things moving and help them with, you know, Q&A here and there as needed. So feel free to reach out to me with any questions. My email, snasr@nistechnologies.com. You can also connect with me on LinkedIn, and then you can find all my socials on Linktree. And so with that, let me check one last time if there's any questions or comments, and there is none. And so with that, I'll turn it over back to you, Lee. Thank you all for having me. It was really appreciated. I loved all the questions. It made for a great conversation. And again, let's keep the dialogue moving. If you try this at work, you want to implement it, or you're looking for some way to implement it on a current table or a database, I'm more than happy to help.
Awesome. Great presentation. Thank you so much, Sam. Really appreciate it. And
Thank
thanks everyone for coming out virtually tonight, and I hope to see you in January. So again, no meeting in December, but hope to see you possibly in person, maybe in One Loudon in January. All right. Thanks. Have a great one, everyone.
Yeah, right.
Talk to you later.
Good night, everyone.
All right. Thanks, everybody.